Okay, we'll start out with some simple systems of linear inequalities and then kind of work our way up. Basically, when you want to graph a system of linear inequalities, you want to graph each inequality using the methods from the previous section and then shade each region with a different color or a different type of shading. And then we want to look for the overlap. So the overlap region is going to be the solution to the system of inequalities. So let's say I have the system 2x plus 3y is greater than 12 and 2x minus y is less than or equal to 2. Now I'm going to go ahead and graph these two inequalities on two separate grids, and then I'll show you what happens if you overlay them on top of one another on a third grid. So, because actually if I did this, I wouldn't do it with two grids, I would do it all at once, but I think you might be able to follow it easier if I show you this way. So the boundary for the first one is 2x plus 3y equals 12, and you saw in the first video all you had to do was just find the y-intercept, which is 0, 4, and the x-intercept, which is 6, 0, and then you can plot the points. So you just, here's the 0, 4, and then here is the 0.60, and so I know that the boundary must go through these 2 points, and also since there's no equal to with this inequality, I would draw a broken boundary or a dashed line through those points. And then if I test the origin to see which side to shade, notice the origin is actually below the line. So if I plug 0, 0 into this inequality, it's going to give me the statement that 0 is greater than 12, which is false. So that means I have to shade everything on the other side of the line, which would be all the points above the line. So that would be this region here that you see I've got shaded in. And so that's for that graph. Now the other graph, the other inequality, 2x minus y is less than or equal to 2, the boundary would be 2x minus y equal to. And if you let x equal 0 and solve for y, you get negative 2. So the point 0, negative 2 is right down here. And then if you let y be 0 and solve for x, you get the point 1, 0. And the point 1, 0 is right here. And since this does have the equal to with it, you would draw a solid line through there. And here's the test point right here, 0, 0. So if I plug 0, 0 into this one, notice I get a true statement. 0 is less than or equal to 2. That should say less than or equal to. But 0 is less than or equal to 2, which is a true statement. So this time I shade on the same side as my test point. And you can see my test point is actually above the line. So I shade everything above the line. In other words, everything on this side of the line gets shaded. Now, the solution... So that's the solutions to each of those inequalities, but actually I want the solution to this entire system. So the solution to this entire system would be where they overlap. And if you lay the first one, okay, here's the boundary for the first one, and remember we shaded everything above here. And then here's the boundary for the second one, and we shaded everything on this side for that boundary. So if you look for where the overlap is, you can see that the overlap is actually, let me see if I can draw it for you. If I can find my, alright, so it goes there and then up through there. Okay, now the only thing about me drawing it like this part right here must be broken, so just make sure you realize that should be broken. And then this part over here is solid, and then the region that we're trying to highlight here is this dark green region that's in here. And notice that region goes up, up, and up, and up. Now, one thing that you'll need to know later, and we'll get to that in another video, is you'll need to be able to find what this is called a corner point. This is actually a corner of the region. And so if you wanted to find that point where those two lines intersect, all you do is solve this system of equations here that makes up that point of intersection. So if you solve the system of equations here using any of the methods we learned from the last module, you'll actually find that this point is 9/4 and 5/2, or 2 1/4 and 2.5. Now, another thing I want to mention is this is an unbounded region because actually it goes on forever and ever and ever in that direction. So that's an unbounded region. And so an unbounded region is one that can't be closed in, and a bounded region is one that can be closed in. Okay, so that's how we graph a system of linear inequalities. Okay, here's another one. I'll do it the same way. I'll just do two grids and then do the overlap. So here 2x plus y equal 10 would be the boundary. And I think you all know how to find the intercepts now. If x is 0, y is 10. If y is 0, x is 5. So this goes through the point 0, 10, which is right here, and the point 5, 0, which is right here. And the line should be a solid line since it has the equal to with the inequality. Then test your origin. So plug the point 0, 0 in, and you'll get 0 is less than or equal to 10, which is a true statement. So we shade everything on the same side as the test point. So therefore we shade everything below the line. And so that would be, you know, this pink region that I've got shaded here. And then the other one, x plus 2y is less than or equal to 8. The boundary would be x plus 2y equal 8. So again, to get the y-intercept, let x be 0 and solve for y, and you'll get 0, 4, which is right there. And then let y be 0 and solve for x, and you'll get 8, 0, which is about right here. And then you just draw the solid line through those 2 points. And then again, you want to test the origin and plug the origin in, and if you plug 0, 0 into the inequality, you get 0 is less than or equal to 8, which is true. So we shade everything below this line as well. Now, so if we overlay these two now on the graph, here's the first one. Here's the first line that I graphed, and remember we shaded everything on this side of that line. And then here's the second one that I graphed, and we shaded everything on this side of that line. And now you can see that the dark green region here is the overlapping region. See? Because if you look at these other regions, obviously there's nothing out here. Here you only have the pink region. Here you only have the light green region. And the overlap is this dark green region. So therefore, when you look at this, you can see that it's bounded there, and then the boundary changes as you go down through here. And of course the region goes on forever. There's nothing keeping it from going on forever and ever in this direction, so this would be an unbounded region. Now a little bit later we're going to actually see that if we restrict this to the first quadrant, we would only have this region in here. And if that were the case, then we would say it was a bounded region, but for now we don't have that. We don't have anything restricting us to the first quadrant yet. Okay, now how did I get this 0.42? Well, that was easy. Remember, one of these lines was 2x plus y equal 10. The other line was x plus 2y equals 8. So basically all I had to do was just solve the system that makes up that point, and then that's how I got the 0.42. So again, solve that system of equations either using the elimination method, or you could use matrices, and you'll get that 4.2 is that point. Now, and then make sure you emphasize the overlapping region when you graph a system like this. So notice here I've obviously identified this as the darkest region, so that emphasizes the overlapping region. Okay, so that's all I'll talk about on that, and in the next section I'll introduce the concept of these corner points that I've mentioned.